al-Khalili, who will be in conversation with William Dalrymple. So without further ado, William, it's all yours.
First of all, I'd just like to say how proud I am of all the Jaipur Literature Festival team for the speed with which they turned everything round today. Incredible innovation. We've been secretly dreading winter rains, which happens about once every 10 years since we started the festival. And we hadn't really got any contingency operations in plan. So seeing everybody huddled together happily in the dining room, it reminded me of one of those sort of wonderful camping trips that goes when you're a kid, or wartime spirit. Anyway, well, and thank you lot for turning up, not deserting us. Stepping into the breach in another way is Jim al-Khalili, who is one of the UK's most brilliant communicators of matters scientific, and has made a huge following for himself on BBC, and very proud to be introducing him to Indian audiences here. Speaking on an incredibly important topic, centuries of Orientalism and Islamophobia have eclipsed the contribution, have airbrushed the contribution that the Arabs made to science, and the way that, as well as innovating themselves, they acted as a storehouse of knowledge by their mass program of translations from classical Latin, Greek, and Persian, and channeling them all together, passed them through Islamic Spain and back to Europe again. And many of the texts that medieval monks and early humanists in Italy were using had come from the classics via Arabic, something which got completely forgotten. It's a story that is there also in art. There's brilliant work being done by art historians on the incredible contribution that Islamic art made to early European art. So gradually we're beginning to recover the full complexity of pre-modern globalization. Anyway, I'll hand you over to Jim, who's going to talk for 40 minutes. It's not a discussion, it's going to be a talk. And then I'll ask a question or two and throw it open to you guys. Go for it.
Thank you very much, Willie. Okay, well, good morning, everyone. Apologies to anyone who was hoping or expecting to hear Sam Weinberg give her presentation. But I think she's involved in 3 sessions today, so I think she felt the pressure and asked me if I'd step in, and I was very happy to talk about this subject. Let me just first explain why I've written a book called Pathfinders, on which this discussion is based. So I'll say why I feel qualified or motivated to have studied and written about this topic. Although I'm a British physicist, I was born in Iraq. So I spent my childhood and my youth in Iraq and left in 1979, in fact, when within weeks of Saddam coming to power. My father knew that was the time to get out, and it was very, very wise of him. So having then studied science, studied physics at university in the UK, and then went on into academia, I'm now a professor of physics, in recent years, I felt this cultural pull to explore and study, I guess, the scientific heritage on my father's side. Because we all learn science at school in a very Eurocentric picture. The greatest scientists are Newton and Einstein and Bohr and Faraday and Rutherford and Marie Curie, all European, all white. And in particular in Europe, but actually in most of the world as well now, we forget that science isn't the preserve of the West, of Europe. It's not something that is the invention of a particular culture or civilization. Science is universal. Science is about understanding nature and how nature works and our place in the universe. And that isn't culture dependent. It's the same everywhere. And as throughout history, civilizations rise and fall, science, the body of scholarship, the body of learning, develops, progresses, gets handed on from one group, from one civilization or society, culture to another, like a baton in a relay race. And each time, someone adds more to it. Sometimes a lot of scientific ideas are reinvented, rediscovered, and as though for the first time, and you forget that someone many hundreds of years before already understood this thing. In the West, we learn that the ancient Greeks were very clever, the Greek philosophers. We still know their names, household names: Plato, Aristotle, Euclid, Ptolemy. And then Europe went into the Dark Ages after the fall of Rome. And for 1,000 years, Europe was just scratching around in the mud and the filth. And they assume in Europe that the whole world was in the Dark Ages, forgetting that there were great civilizations in India, in China, in the Islamic Empire. So my story is focusing on the medieval work in the Islamic world. I'm not telling the story of Indian science or Chinese science. Those are fantastic stories to be told by others who know more about that subject. I want to tell you about what took place between the early 9th century AD and really on until the 13th, 14th, 15th century, although many historians would assume that this golden age of science in the Islamic world died much earlier. It didn't, it continued. I should also explain a definition. It's a very important notion. When we talk about Greek philosophy, we tend to mean ancient Greek philosophy. We know where it is. It's the great, the schools of Athens and later Alexandria. When we talk about European Renaissance, we know what we mean, or the scientific revolution in Europe, we know what we mean. If we talk about Indian or Hindu science, we sort of know what we mean. We're probably talking about people like Brahmagupta, Aryabhata, the great names of Indian science in the medieval period. But what about the science carried out under the umbrella of the Islamic Empire in medieval times, stretching all the way from what is modern day, I guess, Pakistan, Afghanistan, all the way to the West and to Spain, Andalusia, and everywhere in between. The Islamic Empire was vast. What do you call the scholarship and science that took place there? Well, I don't want to call it Islamic science. Science should not be labeled by the religion of those who practiced that science. In any case, during this period, there were many great scientists and scholars and philosophers and writers who were not Muslims. There were many Christian scholars, in particular working in medicine. There were many great mathematicians and translators who were Jewish, or Zoroastrian, or Sabian. There were lots of different multicultural, multi-ethnic, multi-religious groups under the umbrella of the Islamic Empire. Also, you should not, I would never say Christian science. Well, if I did, I would mean something quite specific, a particular movement in the West, which maybe is not quite as respectable as it sounds. Jewish science was used as a derogatory term by the Nazis in the 1930s and 40s to denigrate and downplay the work of the great physicists in Europe at the time, people like Einstein. So the Nazis referred to Einstein's work as Jewish science, implying it was of lower quality. So there are dangers in referring to science as this period as Islamic science. Nor do I call it Arab science. More than half, the majority of the greatest scholars, if I were to draw a list of the greatest names, my top 20 scientists of the medieval Islamic period, most of them would not be Arabs. Most of them would be Persian, coming from Central Asia, coming from Iran and elsewhere. But I do call it Arabic science. And that's not my definition, that's the definition of historians of science now, because the language that the texts were written in was Arabic. The official language of the Islamic Empire was the Quran, the language of the Quran, Arabic. And so everyone who wanted to have, just as English now is the international language of science, for something like 6 or 7 centuries, the international language of science was Arabic. So anyone who wanted to publish their work on astronomy or medicine or mathematics, even if they weren't Arabs, they had to learn and write their text in Arabic. So it's called Arabic science. It began in Baghdad. It began with a new dynasty, the Abbasid dynasty. They were the second big dynasty of Islam after the Umayyads, who were based in their capital, Damascus. The Abbasids built a new capital, Baghdad, which happens to be the city of my birth, so I'm pretty proud of it. They were very influenced by Persian culture. So although Arabic provided the language for this new movement, this golden age, many of the ideas came from Persia, from India, and actually also from the West, from Greece. In Baghdad, under the Abbasids, was born a wonderful translation movement. From the late 8th century, and for probably a couple of hundred years, the Abbasids were obsessed with translation. Any text they could get hold of that they thought was worth reading, they would translate into Arabic. Some of the most famous texts were obvious ones. They wanted to find out about the work of Aristotle. They wanted to find out about the mathematics, the geometry of Euclid. Euclid's Elements was a in fact, the geometry we learn at school over 2,000 years later is essentially Euclid's Elements, still. Ptolemy, a great astronomer based in Alexandria in Egypt, wrote a book we now refer to as the Almagest, which was a compilation of everything the Greeks knew about astronomy. That was the textbook on astronomy that everyone had to read, probably all the way until Copernicus and his book, De Revolutionibus. So for well over 1,000 years, this was a textbook on astronomy. So obviously that they had to translate into Arabic. Then there were books on medicine by people like Galen and Hippocrates. There were books on, Ptolemy wrote a book on geography. So there were standard texts that people knew about that they had to translate into Arabic. Mostly the great Greek texts. A lot of the Greek texts were translated into Sanskrit or into other languages, into Syriac, the language, the written language in the Middle East. And so they were then translated from Sanskrit or Farsi or Syriac into Arabic, sometimes more than once. Once these texts had been translated, a lot of the scholars in Baghdad started to develop their own ideas and extend this work. The most famous caliph of the Abbasid period was Harun al-Rashid. Now, Harun al-Rashid is a character that appears a lot in The 1001 Nights. So that's where many people in the West know about him. He's, although a real caliph who presided over Baghdad in its glory period, he appears as a character wandering the streets of Baghdad with his vizier Ja'far and talking to the masses. And there's lots of stories about him. But it was his son, al-Ma'mun, who was the great patron of scholarship and science in the Abbasid period. Al-Ma'mun was obsessed with books, obsessed with learning, obsessed with science. It's said that he had a dream that Aristotle came to visit him and told him that the most important thing is learning, most important thing is books. And he would, as the Islamic Empire spread and conquered surrounding civilizations and dynasties, rather than asking for money, for gold, for taxes, al-Ma'mun would ask for books. Wherever they conquered, he would say, bring back whatever books on scholarship, on any subject you can find. During his reign, we now believe grew this almost mythical center, the House of Wisdom. In Arabic, it's called Bayt al-Hikmah. Historians aren't sure where exactly physically this House of Wisdom was, this academy, what its purpose was. Some would would like to downplay it and say, well, it was nothing more than a translation house. Some would say it was just a library, a storeroom of books. But actually, the absence of evidence doesn't mean that it didn't exist at all. We do know that there were many translators based in Baghdad. We do know they were under the patronage of the high society of the Abbasid dynasty. And we do know that a lot of great ideas and great works flowed from there. I want to give you a few examples of some of the great scholars. For me, as a scientist, of course, I'm interested in the ideas. I'm interested, as I'm a theoretical physicist, so I'm interested in solving equations of quantum mechanics and relativity. I'm interested in the mathematics and doing calculus and writing computer programs. But actually what inspires me and what inspires a lot of people about science are the characters. Those great scholars who first thought of these ideas. How did they come to understand the nature of our world, the nature of the universe, the laws of nature? And so, for me, bringing the subject of Arabic science alive, this golden age alive, is through the characters, through the people. One of the most famous mathematicians in history was a Persian by the name of Khwarizmi. Now, Khwarizmi was based in Baghdad. He was Persian, but he wrote in Arabic. He wrote what is now regarded as the first book on algebra. In fact, the word algebra comes from the Arabic, al-Jabr, the completion. Kitab al-Jabr, the book of completion, was his text in which he laid out the rules of carrying out algebraic manipulation. So we all learn at school about x and y and how you x plus y equals 3 or x squared plus 2x minus, quadratic equations. You learn how to solve them and find the value of x. That was done to some extent earlier with Khwarizmi. So Brahmagupta, the Indian mathematician and scholar, was solving equations which were first developed by the ancient Greeks. Even the ancient Babylonians were solving quadratic equations. But none of these people were really doing algebra as we understand it today. They were working in what we would now call number theory. The actual recipe for take x from one side of the equation to the other, multiply the equation by 3, then divide by this. That recipe, those steps that you have to follow to solve an equation, which we now call an algorithm, the word algorithm comes from al-Khwarizmi's Latinized name, algorithmus. So not only does his book give us the word algebra, his name gives us the word algorithm, which is the recipe, the set of rules we use in algebra. His book was not only the first one to lay out clearly this recipe for solving algebraic equations, it was also fascinating because it was a book containing no formulae whatsoever. Can you imagine a textbook on algebra now without any equations, without any maths? Here was a book written entirely in prose. He would say, you take the unknown, what we now call x in the West. In Arabic, it was called the thing, al-shay. So you say you take al-shay and you multiply it by itself. Then you add to it 3 times al-shay, and the answer is 10. Here is how you work out what al-shay is, and he will go through but he would do it all. He would probably take him a page or page and a half to solve something that nowadays would take us 2 or 3 lines of algebra. So he could have done it more succinctly had symbolic algebra been around then. Of course, it wasn't. It didn't really develop properly until Europe and people like Descartes. The other important thing about his book was that it was one of the earliest books popularizing mathematics for the masses. The book is divided into 2 halves. In the first half, he does the algebra, gives all the algorithms and the recipes. In the second half, he applies it to real-world examples and problems. So he was saying, here's a book that is useful to society. It's useful in agriculture, so you can work out how to divide up lands. It's useful in working out taxes. It's useful in working out inheritance. And there's this wonderful, I can't remember exactly the wording of the example. I quote it in my book, where he says, imagine, a father has 3 daughters, and he also has a slave, and the slave has 2 daughters, and he emancipates the slave. The slave is given his freedom. When the father dies, one of his daughters gets married, and it gets very complicated because, of course, in the Islamic law, certainly back then, it was very carefully calculated as to how much the son should inherit from the father, how much the daughter should inherit. If you emancipate a slave, how much you give to your slave, how much the slave will give to his children. And he gives this example and then works through it. So it was a textbook that was useful for people. Khwarizmi's book and Khwarizmi's work then went on to be of tremendous importance for other subsequent mathematicians who developed his work further. One of the greatest medieval mathematicians that came after him is Omar Khayyam, the great Persian poet. So certainly in the West, we know Omar Khayyam as a poet. He was okay as a poet, but he was brilliant as a mathematician. He was one of the greatest mathematicians in history. I prefer him as a mathematician to a poet. So Khwarizmi is one of the great characters. Many of the philosophers of Islam were Persians. One of the few who was an Arab philosopher was al-Kindi. He was known as the philosopher of the Arabs. Again, like Khwarizmi, he lived in the first half of the 9th century AD. And like Khwarizmi, he was based in Baghdad. He was the first person to understand Aristotle and Plato, in particular Aristotelian philosophy, and merge it with Islamic theology. This was a time, remember, this was a time in early Islam when the Muslims were not nervous about their faith, worried about pressures from outside. They were confident in their faith. They were confident enough to want to go and explore and understand the world. Sometimes we see in the Islamic world today a nervousness about science, that somehow science is an atheist Western construct to be treated with some suspicion, that somehow it would go against the teaching of Islam, against the teaching of the Quran. 1,000 years ago, the greatest scholars were polymaths. So they were mathematicians, they were philosophers, they were also theologians. They were very devout in their faith. And they understood that the Quran told them, go out and seek knowledge wherever you can find it, even if you have to go as far as China. Seek knowledge from the cradle to the grave. They were told to go and embrace and understand and try and understand the workings of nature, with which they could come back and better understand the words in the Quran. So al-Kindi was this philosopher who brought together Islamic theology with Greek philosophy. There would be many other philosophers after him that would extend his work. A Turk by the name of al-Farabi, and then of course the greatest scholar of Islam, Ibn Sina. Ibn Sina would then influence Christian theology and Jewish theology. Maimonides, the great Jewish scholar from Andalusia who then settled in Egypt, he was a big fan of Ibn Sina. And he said, well, if you can understand and appreciate Greek philosophy and combine it with Islamic theology, can we do it for in Jewish and Christian philosophy as well, theology as well? There were many great translators who would work on a work, say Ptolemy's Almagest, and they would translate it, and then they would realize there was something wrong there, and they would then decide to go out and carry out their own measurements to see if their translation, if they misunderstood something from these great Greek texts, or maybe the Greeks were wrong. And they developed a movement in the Islamic world called the doubts. Al-Shukuk is known in Arabic, whereby they would say, just because something has been given to you by this great Greek scholar doesn't mean it's 100% correct. Go out and check for yourselves. And some of them were criticized for this. How dare you think you know more than these great names? But actually what they were doing was science. They were following what we would now regard as the scientific method. One of the greatest examples of this movement was another Arab scientist, a physicist in fact, so he's one of my favorites, and his name was Ibn al-Haytham. His Latinized name is al-Hazin, but as you might imagine, I would prefer to call him by his Arabic name, Ibn al-Haytham. Al-Hazin comes from the Latinized version of his first name, al-Hasan. He was born in Basra in southern Iraq, and a lot is known about him, a lot was written about him. So we have this wonderful, this colorful character to draw on. His mother and father both worked as what we would now regard as civil servants in the Abbasid Empire in the late 10th century, and he was given a job, an administrative job in Basra, which he hated. It was very boring for him. What he wanted to do was go and study philosophy and astronomy. He wanted to go and read Ptolemy's Almagest and understand about the heavens. But it was difficult for him to find the time, difficult for him to get out of his day job. There's a later example of someone like this, Albert Einstein. Albert Einstein had a job as a clerk in a patents office in Switzerland. Luckily for Einstein, his job was very boring and had a lot of free time, so he could spend his time just thinking and contemplating and coming up with a theory of relativity, for instance. Ibn al-Haytham decided he needed to have a lot more time. So what he did to get out of his work was to feign madness. He pretended to be mad and got the sack, allowing him the freedom to then study astronomy. He later learned that there was a new dynasty in North Africa, the Fatimids, who had just built their new capital, Cairo. And the caliph, the Fatimid caliph there, known as the Mad Caliph, by the way, so you don't want to sort of get on his wrong side, was very worried about how they might regulate the floods of the Nile for irrigation. Ibn al-Haytham had this wonderful idea. Why not build a dam across the Nile, somewhere where in modern-day Aswan, actually, funnily enough. So he wrote to the caliph and said, I have this idea. I have this engineering project I can design for you to build a dam across the Nile to regulate its floods. So he's invited over to Egypt. It's not clear whether the caliph travels down with him to Aswan or not. But when Ibn al-Haytham gets there, he realizes he's bitten off more than he can chew. He realizes this is a far bigger engineering project than he can cope with. He doesn't know what to do. He said, well, I've now promised the mad caliph that I'm going to build him a dam, and if I don't, he's going to chop off my head. And then he remembers this great plan of his. It's worked once before, it might work again. He feigns madness and saves his neck. Instead, the caliph puts him under house arrest back in Cairo. And that's where he spends the next decade or so. So this is between the years 1010 and 1020 AD, just the beginning of the 11th century. He's there until the caliph dies. After that, he is released. But it's during those 10 years that Ibn al-Haytham writes some of his greatest work. He writes a book on optics, Kitab al-Manazir, which for me is every bit as important in history as Isaac Newton's book on optics 700 years later. See, we learn at school, again, here's the Eurocentric teaching of science. We learn at school that it was Isaac Newton who first messed around with mirrors and prisms and light and so on. Going all the way back to the Greeks, going all the way back to Archimedes, scholars were playing around with lenses and started to learn about the focusing of light, the diffraction, the spreading out of light, the refraction, the bending of light, the reason you see a spoon bent in a glass of water. This was all being studied. Ibn al-Haytham extended this work. In his book of optics, he was the first person to explain how we see. Until then, And I don't mean the physiology of the eye, but simply the physics of how we see objects. The Greeks couldn't agree whether we saw an object by light coming from the object into our eye, or whether we shine light from our eye onto the object, like Superman. So people like Plato and Euclid, the great mathematician, they had this mathematical theory of light traveling as rays, ray diagrams that we learn at school, again with arrows going through lenses and coming together. But they had it the wrong way around. They thought light shines from your eye onto the object. They said, how else can you pick out a detail? If I look at this table and my eye is drawn to a particular spot on the table, they said, if light is coming into your eye from every point in the table, how can you pick out detail? Surely by seeing something, you must be shining light on it. Aristotle, the other great, he was the pupil of Plato, he had a different idea. He said, no, light enters our eyes from our surroundings. But he didn't develop a mathematical picture for it. Aristotle wasn't a mathematician. He was a thinker, he was a philosopher. He thought in the abstract. And he said, no, light permeates everything and enters your eye, and then you figure it out. He didn't really give any details. What Ibn al-Haytham did was bring these ideas together. He said, Aristotle was right, light enters your eye from the object, but Plato and Euclid were right in using geometry and ray diagrams. What Ibn al-Haytham then did was carry out experiments to show for the first time that light travels in straight lines. Talking about angles of incidence and reflection, he develops all of that in his book, Kitab al-Manadhar. He is now regarded by many historians of science as one of the earliest practitioners of the scientific method. Again, the Eurocentric story is that the scientific method was developed by Descartes and Bacon in Europe. Actually, it goes back a lot earlier than them, back to the early 11th century, and people like Ibn al-Haytham. What do we mean by the scientific method? We mean you don't just believe something because someone tells you. If you have a theory, a hypothesis, an idea about a phenomenon, a mechanism, the way something happens in nature, what you have to do is test it. You have to come up with an experiment to get evidence, empirical, experimental evidence. And if that evidence supports your theory, then your theory survives to fight another day. But it's always being tested. There's always the chance that someone will come up with a new experiment that conflicts with the predictions of your theory, and then you have to kill it. You have to give up on that theory. This is where science is very different to theology. They're very different to faith. In science, you cannot believe something 100%. There would always be the chance that your theory is wrong. Ibn al-Haytham wrote all of this down. He said you have to test. You have to carry out experiments. You cannot believe what other people told you, however famous they might be, great Greek philosophers. Test it for yourselves. The other two characters I want to talk about briefly, because I want to say something about the decline of the Golden Age, and I want to finish in about 7 minutes to give you time to ask me questions. There were all actually contemporaries of Ibn al-Haytham. Ibn Sina, who I mentioned before, the great philosopher and actually medic. He was the greatest physician of the medieval world. Ibn Sina is said to have learnt everything he needed to learn about medicine. Well, okay, not so much was known 1,000 years ago as is known now, but he did manage to write a multi-volume text on medicine called the Canon of Medicine. In it, he wrote about anatomy, he wrote about illnesses, he wrote about medicines, he wrote about surgery, everything that was known about medicine and physiology at the time was in Ibn Sina's book. A lot of it was based on superstition and wrong-headedness, as indeed it was by the great Greek medics. People like Galen, who was until Ibn Sina, Galen's texts were the ones that everyone studied. But there were a lot of important discoveries, a lot of important bits of information there. So important was the canon of medicine that it was the recommended textbook in medicine everywhere in the world, well, certainly in the older world, certainly in Europe, until about the 17th century, maybe even into the 18th century. Can you imagine a textbook now, when students at university, when their professors recommend a book for them, very often it's superseded, certainly in science, maybe not in the humanities and literature and art, but in science, a book comes to the end of its shelf life and is superseded by a more modern text. Ibn Sina's Canon of Medicine was the recommended textbook on the shelves of the libraries of universities in Paris and Oxford and Cambridge for 700 years. Ibn Sina was a superstar. He was the most famous scholar of Islam. All the courts of all the dynasties and around Asia would love to have had him. It's a bit like a top footballer today, Ronaldo or someone like that, being bought by the top clubs around Europe. You know, Real Madrid will say, okay, we'll pay you whatever you want, we want this player. And then Chelsea say, how much do you want? And Manchester City say, okay, we'll add another zero and we'll buy him. Everyone wanted to buy Ibn Sina, by which I mean offer him patronage, pay him to come and work in their courts and give lectures and talk about theology and philosophy and so on. A contemporary of Ibn Sina's, less well known, maybe better known in India, is Biruni. Biruni was a Persian scholar who lived probably around modern-day Afghanistan, Pakistan, just as clever as Ibn Sina, also a genius. I would refer to Biruni as the Da Vinci of the Islamic world. There wasn't any area of science and scholarship that he didn't have some influence on. He wrote a book on the history of the world. He wrote a book on the geography of India. He was the first person to write about geology. He was writing about the geology of India and how how the land masses developed and evolved over time. He wrote a book on astronomy. He wrote on trigonometry. He's probably, in popular science, he is best known for carrying out the most accurate calculation of the size of the Earth. This idea that we didn't know the Earth was round until Christopher Columbus goes all the way around is nonsense. Even the ancient Greeks knew the Earth was round. You could tell the curvature just by seeing a ship coming up over the horizon. Biruni extended the ideas that the ancient Greeks had done in calculating. What the Greeks would do, you see, is they would look at something like the sun, or the sun casting a shadow into a well, and they would measure the change of angle if they walked. So a great example was a scholar started from Alexandria and measured the angle of the sun, and then walked south round about to Aswan to measure how much the angle of the sun would change at the same time of day, same day of the year. And the distance, and he knew if that was 1 degree, then he needed to multiply by 360 to come all the way around. So he said, all you need to do is measure the distance you have traveled for the sun's angle to change by 1 degree and multiply that distance by 360. And in fact, that gave the Greeks a pretty good estimate of the size of the Earth. Biruni does a much better trick. I can't really go into the details because it involves a bit of trigonometry, but essentially he finds a mountain in Pakistan, a mountain overlooking a flat plain because he wants to be able to see the horizon. He first measures the height of the mountain using some very clever geometric trick with a square with marked length scales along its side, and measures basically using an idea called parallax to measure the height of the mountain. So he knows how high this mountain is, a few hundred meters. He then climbs to the top of the mountain with an astrolabe and measures the angle of inclination to the horizon. So he measures the height of the mountain and this little angle, less than 1 degree. And from that, he then just uses mathematics to work out the radius of the Earth. And then multiplies it by 2 pi, as everyone knows in maths, to get the circumference of the Earth. He gets to within 1% of the 25,000 or so miles. An incredible achievement, not so much because it's so accurate, but because of the ingenuity of his idea. Biruni and Ibn Sina actually write to each other. They have this long-running correspondence about metaphysics, about philosophy. Biruni says, so the learned scholar Ibn Sina, why does ice float? And Ibn Sina says, well, of course, the learned scholar should know this. It's because ice has lots of little holes in it, full of air, which of course we know is nonsense. And Biruni says, no, I don't think that's it. I think there's something special about ice that makes it less dense than water. But of course, they hadn't developed enough physics to follow this through. They ask things like, how do the sun's rays reach us from the sun? How does heat reach us? If you feel the warmth of the sun, is that heat, that essence, that energy traveling all the way from the sun? Or is it something that happens in your... they were asking serious physics questions 1,000 years ago. Many other examples, and a lot of these scholars' work was later translated into Latin. When Europe woke up again during the Renaissance, they realized that they'd had all this lost heritage, or these great Greek philosophers. Many of these great Greek texts didn't exist in Greek anymore. They only existed in Arabic. So they began by going to the Middle East, to Spain, Andalusia, cities like Cordoba and Granada and Toledo, where they would get hold of Arabic texts, learn Arabic, and translate it back into Latin. So many of these would have been Greek texts translated into maybe Syriac, and then Arabic, and then back into Latin. In the process, of course, they discovered so many great Arabic texts by Khwarizmi, the mathematician, Ibn Sina, the philosopher, Razi, the great medic, Tusi, the great astronomer in Persia, and that fed into European development of science. Someone like Copernicus, who we regard as one of the fathers of modern science. Copernicus was the first person to say Ptolemy's ideas and the Greek ideas about the sun going around the earth is wrong. In fact, the earth goes around the sun. Copernicus was a great genius. He heralded the scientific revolution. Galileo would then prove that Copernicus was right. Actually, the earth is just a planet. You read Copernicus's book, and there he lists the Arabic, Persian and Arab scholars whose work he relied on. A Syrian astronomer by the name of al-Battani, a Razi. He uses their mathematics to develop his theory. And you see that throughout the development of European science. Two things before I end, very quickly. One is to say, very often when I give this talk in Europe, certainly in Britain, people say, oh yes, the Arabs, yes, wonderful, you gave us zero. And so I feel for an Indian audience, I have to say, that of course, zero comes from India, and it was inherited by the Islamic world along with Hindu numerals, decimal system. But of course, when we say zero, there are different things. If we mean zero as a placeholder, just a symbol, to tell us the difference between 11 and 101, then that goes way back. Round about the same time, the Babylonians and the Mayans in Central America had symbols for zero. Also round about this time, about 300 BC, Aristotle was talking about zero, but as an abstract concept, the void, emptiness. But he didn't really think of it as a number. It was the Indian mathematicians, round about the 5th century or so, no one's quite sure exactly when, plus or minus 100 years or so, started using zero as a real number, halfway between +1 and -1, a number that can be used in arithmetic. And that was inherited by the Islamic world. It took a while for Hindu numerals to be taken up in the Islamic world, and even longer to be taken up in Europe. One's never sure why, if the Europeans were still using Roman numerals to carry out multiplication. Try doing multiplication with Roman numerals. It's horrible. You have to learn a whole system, whereas with decimal systems, it's so much easier. But I think the Europeans were very nervous and suspicious of this Saracen mathematics that came from the East, so they didn't want to use it. The other thing to mention very briefly, why did this Arabic science, this golden age, go into decline? Very often people say, well, it was the Mongols sacking of Baghdad in 1258. Actually, there were many centers of scholarship by that time in Cairo and Damascus and Cordoba and Samarkand and Bukhara in Central Asia. So the fact that Baghdad was sacked didn't mean that all scholarship came to an end. Others would argue it's because Islam became more conservative, more orthodox, and turned away from science. Again, this is not true. It certainly happened in theology. So the greatest theologian of Islam, al-Ghazali, who was also, by the way, a great scientist, was critical of the work of Ibn Sina because he saw it as too Greek, too Aristotelian. So there was a theological debate about philosophy. But that doesn't mean that things like mathematics or medicine or astronomy also went into decline. The fact is, in the same way that the golden age of science in the Islamic Empire really benefited from the use of paper, when the Islamic Empire expanded out east and really came up to the Chinese armies and really couldn't go any further into China, what they did bring back from China was the development of paper, which was much cheaper than papyrus or parchment. And so paper was useful in producing many texts in the Islamic world. In the same way, in Europe, with the invention of the printing press, it was a very important development in the Renaissance and the scientific revolution in Europe. The printing press wasn't taken up in the Islamic world. And so I think that was one of the reasons why they went into decline. And also in comparison with Europe, with the Renaissance. The reason why the Renaissance happened was because of money, because of rich benefactors who provide the patronage for the sciences and the arts. The Medicis in Florence, for instance. Without them, would the likes of Michelangelo or Leonardo da Vinci have been able to do what they had done? In the same way, in the Islamic world, the Abbasids were very, very wealthy. They were a very powerful dynasty. The patronage of those who worked in the House of Wisdom was very important. With the fragmentation of the Islamic Empire in later centuries, that became less possible. And I will end by saying that we look now at science in the Islamic world and see how far it has to go to catch up with the first world, the developed world. But there are countries like the Gulf, in Qatar, the Emirates, Saudi Arabia, who are pouring money into new universities, new research labs. And cynics will say that's not enough, and it's true, it's not enough. You can't just build a shining new university and expect to change a culture that in many cases is anti-scientific. But you do need that money, you do need those universities, you do need those laboratories to begin with, and that culture will then change and spread. So what I'm saying is, look out, there may well be another Renaissance, a golden age of science. Whether Arabic will be the language anymore, I think is not so important. I think English is now whether people like it or not, the international language of science. So you go to any scientific conference around the world, you have to speak in English if it's an international conference. But science doesn't develop because of the language it's spoken in. It doesn't develop because of the religion of the people who practice it or the part of the world they're in. Science is universal. The story I've told is simply filling in the gap of our shared history of science. There are many other stories to be told. For instance, the science of India, the science of China. I'll leave that to others to tell. Thank you very much. I've spoken for too long, I know. I even had my watch on the table. I don't know why I bothered.
Fantastic.
Just so you know, Jim was only asked to do this yesterday. To be able to give a talk like that without looking at a single note. Extraordinary tour de force. Jim, I'm sure everyone here wants to know a bit more about the Indian aspect of Arab science. What was the method of transference of ideas like zero from India to the Arab world, and when did it take place?
It really took place over quite a long period. When the Abbasids were first trying to gather all the books they could, a lot of what they got was from India. Now, actually, a lot of, even some of the Greek texts they got from India. You know, we know you know, at the time of Alexander, just how widespread Greek culture extended and intermingled and exchanged with Indian ideas. And so a lot of the texts that they would get hold of would have come from the East, would have come from India. Some of them were Greek texts translated into Indian, others were original Indian texts.
What is the method of transference? Are you getting Indian scholars sort of going to Baghdad, or
are
Arab scholars coming to India and reading Sanskrit, or what's happening?
In both, I mean, originally around in the 9th century, Baghdad was very much the center. And so anyone in the world, in the same way that now if you really, you know, the top scientific places to go to will be Harvard or MIT. There, if you wanted to do science, you wanted to mix with the brightest minds, you would go to Baghdad. And so Indian scholars, not just scientists, but poets and philosophers.
Do we know names? Do we know details?
Without my book to hand, I mean, as you said, I've given a polished performance, but of course, but there certainly was a, no, offhand I can't think of names, but there certainly was a poet who came over, who had spent time in Persia, Indian poet and philosopher who spent time in Persia and then went to the court of al-Ma'mun
And who's that character in southern Afghanistan in the 11th century who writes the first book on Hindu learning?
Ibn Sina was Ibn Sina
yeah.
Certainly, or Avicenna as he's known in the West. He wrote a book on the geography of India. He never went to Baghdad.
Right.
He never made it to Baghdad. He basically traveled around the smaller dynasties in Central Asia, modern day Afghanistan and so on.
Because you have another great moment of learning in India in the 13th century when all the scholars who are fleeing the Mongol hordes from destroyed universities in Afghanistan and Baghdad come to Delhi. And all those ruins that people in Delhi sit in and housecast that are now trendy restaurants, that was a very serious madrasa built by Firoz Shah Tughlaq.
Right.
But I don't know how much that was involved in translating Sanskrit text, whether it was, or how far it was doing its own work or acting as a medium, or presumably it was incoming scholars. I mean, it was incoming scholars with Persian.
Yes, I mean, what I've concentrated on is not so much what happened beyond the mid-13th century. So while I'm aware that you know, centers like Samarkand remained beacons of scholarship, astronomy, and mathematics, I've focused more on those who came to the Middle East, the Islamic world, rather than the other way around. And that would have happened in the early translation period during the 9th century, 10th century.
When's Ibn Sina?
Ibn Sina is 10th, 11th century, yeah.
And one other question, with your name, Jim al-Khalili, you mentioned Syriac again. I've always heard that it was Christian Nestorian scholars in Nishapur and Nisibis on the boundaries of the Byzantine and the Persian world who were acting as the translators from Greek into Syriac and then again from Syriac into Arabic. Is that right?
Yes, I mean, I think you have to say that when we say that Europe was in the Dark Ages, there were Christians and Jewish scholars within their monasteries and synagogues who were preserving the great work of the Greeks and translating into Syriac. Of course, what hadn't happened until the Islamic world, Islamic Empire, which goes and conquers, you know, a big chunk of the Byzantine Empire and the Sassanid Empire to the east, the Persians, is that they bring together, they open up this empire. And suddenly these great scholars, a lot of them, you know, as you say, Christian monks in monasteries, start moving around, start talking to each other. And it's that exchange of ideas, the cross-fertilization.
Within Pax Islamica.
Pardon?
Within Pax Islamica.
Absolutely, yes. I mean, at the time you could convert to Islam if you wanted to. If you didn't, you'd pay higher taxes, but there was no obligation to. And so they had that freedom then to exchange ideas and to show the work that they had done. So thankfully that there were these isolated pockets where the great Greek texts were preserved.
And again, finally, the method of transference from Arabic to Latin.
Yes.
This is happening you said in Cordoba?
It happened, it took longer. It actually even started from about the 10th century. So you would get...
Gerard of Cremona?
Gerard of Cremona was probably the most famous translator who goes and settles in Cordoba, learns Arabic and translates so many other works.
He has a kind of munshi, doesn't he? He has a guy called Ghalib,
Yes.
Who translate? So he's translating from
Well, it would have been Arabic.
From Syriac into Arabic, and then Arabic into Latin. Is that right?
I'd assumed
very
most of the
complicated,
I assume most of the texts that would have reached Andalusia would have been in Arabic already, so it would have been Arabic into Latin. But there were others. Fibonacci, the great Italian mathematician, we hear about the Fibonacci series. He travels to the Middle East. He travels to Baghdad and learns Arabic there.
In which period? In which date?
That would have been around about the 11th century, I think. And he translates, and he goes back, and you can see in his book in Latin, Liber Abaci, he talks about Khwarizmi's algebra, and so he's brought Khwarizmi's algebra to Europe for the first time.
Fabulous. Fabulous. Any questions, guys? We've got about 5 minutes. How long have we got? 5 minutes. Yeah. This gentleman here.
The numbers and the tables, as we call it in English, that's called Hindsa in Arabic. Hindsa. That means what came from India. And what it documents it all is the book Hisabul al-Jabr, or what you call Kitabul Jabr.
Sorry, I didn't understand the point.
The numbers and the tables, as we call it in English. Okay, so the numbers and the
Hold it
tables.
close.
Okay, the numbers and the tables, as we know it in English, that's called Hindsa in Arabic language. That means what came from India. But the book which documents it all is Hisab al-Jabr, or what you refer to as Kitab al-Jabr.
Al-Jabr.
I mean, is that available? As a professor of physics, I'm interested in that. I mean, somebody said, it's available somewhere in Persia. It's preserved, one nice text.
Is the
that
Kitab al-Jabr available still?
Right, because that also documents the journey of zero, the decimal system, and the fundamentals of algebra from India to the Middle East or Persia.
You're asking if that's as evidence that a text available explaining that journey?
Yeah.
Not as much as we would like. There are a lot of texts yet to be translated. There are a lot of texts in libraries in the Vatican, for instance, and in Istanbul, where scholars, historians of science are still trying to learn more. So Kitab al-Jabr, the book of algebra, certainly has been translated. I've seen a 15th century edition of it in the Ashmolean Museum in Oxford. It's available, it's widely available and translated into many languages. And I think in the 19th century it was translated into English for the first time. But the story of how zero and Hindu numerals traveled from India to the Islamic world is not well known. Khwarizmi, al-Kindi were people who promoted it. It's told, I should have my book with me to remind myself of what I had uncovered when writing the book. But there's certainly a Christian monastery in Iraq, near Baghdad, where someone had traveled to India and come back with this set of 9 symbols plus the 0 and said, this is a new way of counting that might be useful. But no one listened to him for a very long time.
One more. Gentleman here.
I'll keep it very short. We might have time for one more.
You've talked about the integration of the ideas from India through to Europe. You mentioned Chinese science, but I was just wondering whether Chinese science was integrated into that system or whether they tended to be more separate.
No, Chinese science is very much isolated within its own bubble. Who's the great scholar of the 1930s who wrote about Chinese science?
In Cambridge.
Yes.
Yeah, I don't think not Wade Geary.
Needham, thank you.
Yeah, Needham. In Keys,
yes.
in Keys, Cambridge.
So Needham has written this multi-text, multi-volumes about Chinese science, but to date, that is still the definitive book on Chinese, the history of Chinese science. So we don't know enough about it. Chinese science didn't integrate and merge with Western science and the science of the Islamic world in the same way as Indian science did. China was very much more isolated. So very often we say, in the 10th century Baghdad, this is the first example of a decimal point. And this is, by the way, my excuse why I don't mind referring to them as Hindu Arabic numerals. Because, you know, why would you give the Islamic world credit for Hindu numerals if all they did was act as the, you know, sort of, you know, passing it on? But the first example we know of a decimal point was by a mathematician, an Arab mathematician in Baghdad. But it might have been in China where they discovered decimal points long before. So we simply don't know, and we think that science developed in isolation and in parallel in China and outside China.
Good question, by the way. One chap here.
There had been examples like Mendel and Kohlreuter's who have used mathematics and biology in Europe. So are there any such examples in Islamic world as well?
Any examples of biology?
Who have used mathematics and biology?
Mathematics and biology. Biology was never one of the subjects that the scholars of medieval Islamic period were that interested in. There were a few. There was a scholar in Baghdad by the name of al-Jahaz who wrote a book called The Animals. I mean, Aristotle, by the way, I think wrote a book called The Animals as well. Al-Jahaz wrote a book on biology where some historians have even argued that he had come up with some rudimentary theory of evolution. He was asking about how different groups of people or different animals, you know, why does the fox and the wolf look like the dog, and did they have a common ancestor? So Al-Jahaz was probably one of the few examples of people using biology at all, let alone mathematics and biology. I think the use of mathematics in the life sciences is something very modern.
Ladies and gentlemen, please have a large round of applause for Jim al-Khalili.
Thank you very much.
Stepping in the last minute. Brilliant.